All right, graphing cotangent is a little bit trickier. All right, you got to remember again, cotangent is going to be the reciprocal of tangent. So all my tangent values are going to be flipped over. And when we graph tangent by looking at the sine kind of dots. They look like tangent comes from like the sine dots. What I mean by that is if we graphed sine, but the period is pi, if we graph sine, it'd look like this. Sine would kind of look like this. There's sine. All right. Now, from that, you can see the dots hit the same spots as sine. Now, tangent, though, when we went through here, tangent, what you remembered, it had an asymptote down the middle. But the reciprocal of an asymptote, or 1 over 0, is 0. Oh. So where it was an asymptote is now 0. But where we had a 0, remember we had zeros? The reciprocal of 0 is now an asymptote because the reciprocal of 0 is 1 over 0. So right here is an asymptote, and so is this. So we have to watch out for that, all right? The 1s and negative 1s stay the same. The zeros are actually 0 now. I mean, the middle 0, which was an asymptote, is now 0, but where it was 0 for tangent are asymptotes, vertical asymptotes. So it's a little bit tricky. One thing you basically look for is, well, on tangent, the asymptote is down the middle. On cotangent, it's on the edges. And cotangent normally has a dropping effect. And so you just kind of draw it in between. All right, I want to graph the opposite of cotangent theta, or negative cotangent theta. So it's going to be cotangent kind of flipped. So cotangent comes from tangent. So to draw tangent, we first know our period is going to be pi, since it's not been adjusted. So our period is going to be pi, and halfway through would be pi over 2. Well, your vertical stretch, since there is no adjustment here, is simply going to be 1. So up and down 1 is your vertical stretch. Now, next, to graph tangent, what we do is we graph sine, just to help us out. So if we graph sine, sine starts here, but since it's negative, it's going to go down first, then it's going to hit here, then it's going to go up, and then it's going to hit here. So what you see for sine, because we're using the sine dots, we're not actually graphing sine, we're using the sine dots, is it would look like that. Now, if tangent went through that, now tangent normally has an asymptote right here, but on cotangent, an asymptote or undefined becomes an actual 0, so that's a good dot. These stayed the same, but this one, well, this was 0 for tangent. The reciprocal of 0 is undefined. So what you have to watch out for in these kind of problems is with cotangent, your asymptotes end up being on the edges. All right? And then you graph your cotangent through these dots right here. So we're going to graph cotangent through those dots. So if we're going to do that, well, it'll look kind of like this. There is your cotangent. Now, it's a negative. That's why it's going up. It's kind of weird, but cotangent normally drops. Cotangent always has asymptotes on the edges because tangent has an asymptote down the middle. And hopefully you can make sense of all this, and it's making some sense. Cotangent is the hardest of all of them. All right, to graph this cotangent, the first thing we want to do is look right there. That means my midline is 1. So I'm going to go up 1, and that's going to be my midline. All right, and to graph cotangent, we want to think of tangent, and tangent comes from sine values, but tangent also has a period of pi, and since we don't have a b value, our period's still pi, and our vertical stretch is 1. So we know it's going to be pi there, and then halfway will be pi over 2. All right, and then we're going to graph a sine graph to help us out. So right here is going to be 2. So to graph sine, we're going to start here. We're going to end there. End here. Hit there again and end here. And with sine, you go up halfway and you go down halfway. So it kind of looks like this. that's what a sine graph would look like for sine x plus 1. But what's going to happen here is we have to draw some asymptotes and stuff like that. So tangent, again, normally has an asymptote right here. Cotangent won't. Cotangent is going to make your asymptotes on the edges. So for this one, you're going to have asymptotes on the edges here. So boom, there's one asymptote, and along this edge. All right, then what you're going to do is you're going to take the dots that sine gave us, because all those are going to be dots, and your cotangent graph is going to go through those dots, and it will look like this. You gotta get used to it, but it kind of looks like this and goes up towards the asymptote, and then this one is going to go down towards this asymptote, and that right there is your cotangent graph. It gets easier with time, but cotangent always has asymptotes on the edges and has this downward look. If it's negative, it's going to go up.